Okay, thank you. How's everyone doing? Good, nice. Thank you for the patience, I really appreciate it. I was expecting that by now more of you will be leaking to the other talks, but you really want to hear about fake news and technology. So it will be rewarded, I promise, and I promised we will get the time. And I'm also very excited. I'm especially excited, because I got a chance to give this talk to politicians, I got a chance to give this talk to education people, and I talk about the technology part, but I try to keep it high level, not to go too much into details. But today we have this audience of tech-savvy professionals like yourself, so we can dive a bit deeper. So I'm really excited. We'll start slow and easy. We'll see a few examples, really cool examples for how technology is being used to generate fakes with different videos and audio. And then we'll pick up the pace and we'll go a bit deeper. I'm really excited to share with you, I think this is for the first time, a really cool research project that we did recently. We wrote a paper about it and it's going to be presented at NLP in November, so I'm really excited to share that with you. And so, yeah, that's the plan for today. Okay, so let's maybe get started with a little game I like to call Real or Fake. Oh, shit. Okay, pretend that didn't happen. Okay, we have more examples, but let's start with this one. So I'm going to show you two videos. One is raw, unedited footage of Ronald Reagan. The other one is a fabrication by a machine. I'll pretend you didn't see that. Which one of these you think is real? Okay, you guys have seen it, so I'm just going to give it to you. So the left one is actually fake. This is quite a good example because it's based on deep video portraits. This technique is considered state-of-the-art. What they did is they took a portrait of Obama and then they transformed the facial expressions and the hand movements into Ronald Reagan's video, and you see the results are quite realistic. Let's try another example. You guys know Bill Gates, right? So I'm going to play 3 sound clips, and let me know which one of these you think is the real Bill Gates, okay? First one.
A cramp is no small danger on a swim.
Second.
Pluck the bright rose without leaves.
And third.
The glow deepened in the eyes of the sweet girl.
What do you think? Who thinks that the first one is the real Bill Gates? Okay, a few. Thinks the second one? Okay, the third? Okay, so there's no consensus. I think you're quite split. The truth is, I actually tricked you. All of these are fake. None of them is the real Bill Gates, and it's actually based on a work from guys from Facebook research. They used the model that's called the MelNet, and they trained it on a video of Bill Gates, hours of TED Talks, and you see the results are very realistic. Let's try one more example. What do you think about this guy? What is his name? Where does he live? Does he have a family? Well, all of these questions are actually irrelevant because this person doesn't exist. I actually took it from a site that is called This Person Doesn't Exist. And some guy took research from NVIDIA. They released it last year. They trained it on a data set of celebrity faces, and they tried to create real human faces. I remember someone also did something similar for cats. And you can be really creative with these kind of examples. But what are we seeing? What are we seeing in these 3 examples? We're seeing that these models of generating images, generating audio, generating videos are becoming more and more realistic. And we know that fake news is already wreaking havoc on politics and media. So it's not surprising that Gartner, the research company Gartner, they're predicting that with this wave of AI-generated fakes, which we call deep fakes, this will only get worse. But let's maybe take a step back. So what are these deepfakes? So we know in the last few years, we have seen quite huge advancements in AI, and especially with deep networks, and especially with one type of deep networks that's called GANs. Have you heard about GANs? Yeah, nice. So the guy here, a young Goodfellow, rightfully nicknamed the Gunfather, is the guy who invented GANs. GANs stands for generative adversarial networks. Generative because they generate images and videos. Why adversarial? Because of their concept. So basically two networks put one against the other. You have a generator, tries to create an image, and then you have a discriminator who gets that image from the generator and tries to decide whether it's real or fake. Okay, and then it feeds the result back into the generator, and you run both of them one against the other through lots of iterations, and both become much better over time. And this is a really powerful concept. If you search online awesome GANs, you would see beautiful examples. People get really creative with this kind of stuff. But as we know from one of the comic books, with great power also comes great responsibility, right? And we're starting to see what happens when people take advantage of this technology, not necessarily for the right reasons, which brings us to the next chapter of bad AI. So let's start with this example. What do you think? Cool? Awesome? Scary? Okay. So what you are seeing is that not only it's getting more realistic, it's also getting more accessible. Okay, so if you want to create this kind of fakes, you don't need to do any coding. There's even an app for that, the Fake app. I'm curious, by the way, did anyone here try to play with this app before? No? For educational purposes, of course? No? Okay. If you're even too lazy for an app, imagine that you could take a video and take the text of that video and change it to make it seem like the person in the video says what you want it to say. So this was actually the idea of these researchers from Stanford.
In this work, we present the first text-based video editing approach that lets editors insert new text in addition to cutting, copying, and pasting the existing transcript text. Our approach allows editing at any point and synthesizes the corresponding correct, lip-synced video.
Okay. The market closed today with Apple's stock price at $191.45 per share.
Here we replace 91.4 with 82.2.
Okay. The market closed today with Apple's stock price at $182.25 per share.
Did you notice any difference? No. So what they did here, so remember we saw the example before of the audio of Bill Gates? So they took it a step further. So now you can take the text, generate an audio, but you can also, it's basically an advanced lip syncing method. So they learned how to map the mouth movements into the sound. They teach word making. And you see, the result is very realistic. And talking about audio, do you guys like to listen to podcasts? Do you know Joe Rogan? He's a very popular American comedian. He has a podcast, which makes him a very easy target for this kind of manipulations.
Friends, I've got something new to tell all of you. I've decided to sponsor a hockey team made up entirely of chimps. I'm tired of people telling me that chimps are not capable of kicking human ass in sports. Chimps are just superior athletes. And these chimps have been working out hard. They're throwing kettlebells, battle ropes, everything. I've got them on a strict diet of bone broth and elk meat. These chimps will rip your balls off. God damn, it's impressive. All I got to say is, see you on the ice, folks. Being a robot has its benefits. I can pronounce tongue twisters now. Check this out. Peter Piper picked a peck of pickled peppers. How many pickled peppers did Peter Piper pick? She sells seashells on the seashore. The shells she sells are seashells, I'm sure. Also, since my brain is connected to the internet, I've become a medical expert. Did you know that basilar membrane and otolaryngology are not autocorrelations? Hey, Joe Rogan, it's me, Joe Rogan. Please come save me, man. These artificial intelligence guys have trapped me in a machine. I've never told this story before, but on Thanksgiving weekend, I was doing a set at the Comedy Store, and some idiot ran up on stage. He comes up to me during the middle of my set and tells me that we are in a simulation. The guy was drunk out of his mind. He was so drunk that he couldn't stand up straight. So we all laughed at him and let security escort him out. But now that we have deep fakes and fake voices, I'm starting to believe that we're not far off from simulations after all.
Okay, gotta give it to these guys, quite creative. So we saw an example for a video, this is an example for audio. What about text? What do you think? Can we also make machines generate text automatically? Yeah, we can. Have you heard earlier this year about the story about OpenAI? GPT-2. So they generated a method that can automatically create text. It made the headlines because they decided that it's too dangerous to release it to the public. Eventually, they released a smaller version, but there was also a group of another researchers from Allen Institute of AI who developed this method, Grover. You can go to this link and actually check it out later. And what it does is quite similar, only they took it a step further, so you can now make the text in a specific style. If you want to make it like a CNN story or a New York Times story, you can even make it specific to an individual author. So we're seeing examples for video, examples for audio, examples for text, and these things are quite realistic. One more thing maybe to add is that it's not all gloom and doom, okay? So there's also beautiful, legitimate applications. I don't know about you, but going back to my school days, so this thing would save a lot of time with essays, right? No, but seriously, if, let's say you're scrolling through your feed on Instagram, on Facebook, and you're seeing an ad for Coca-Cola. Imagine that instead of a random model, now you're seeing a deepfake of yourself, drinking the Coke, saying, tastes good. If they take your images and train it, they can generate the deepfake of you, right? There might be a small privacy issue there, but assuming that you gave it your consent. But that's one interesting application, personalized ads, right? What about this? Imagine that we could use the audio model that we saw before to learn Albert Einstein's voice, right? So you could take a chatbot that knows how to answer physics questions, couple it up with Einstein's voice, and then you're practically learning you're learning physics from Einstein himself. How cool is that? So there's also beautiful applications, and if technology got us into this mess, perhaps it can also get us out of it. Which brings us to the next chapter about good AI, so how we can use technology to maybe detect the fakes. So in the past few years, there have been quite a few initiatives in that area. There's initiatives by fact-checking organizations, by Duke University, which the founder of the Duke Reporters Lab is also the founder of PolitiFact. There's one organization in the UK which is called FullFact, which is sponsored by Google. government agencies like DARPA are obviously also involved, and there's also commercial applications like with AdVerifai. So I started AdVerifai 1.5 years ago. You might ask, so what we're doing is, the name implies AdVerifai, we're doing ad verification. And you might ask, what's the connection between ad verification and fake news? So I don't know if you know this, but a lot of the guys that are spreading fake news, why are they doing that? To generate money. So they make a website, it costs them next to nothing, put some ridiculous stories there, they get their traffic from Facebook and social media, and then they monetize through advertising. But unfortunately, advertisers don't want to be associated with this type of content. And that's what we're doing. We're trying to prevent the ads from landing in this kind of sites and basically cut the cord between the fake news perverse and the advertising money. How we're doing that? So we are relying on 3 things. First of all is the technology, which we're going to talk about in more detail in a second. Second, and this is really important, the subject matter expertise. So a lot of the times, we data scientists, we are like walking around with hammers, looking for nails, right? So we now picked up this shiny deep network hammer, and we're walking around trying to find what we can nail down. But the truth is that it's really important to understand the problem that you are solving, to consult with experts from this domain, and that's what we are doing. We're consulting with fact-checking experts, with journalists, and working with them. And this is also very helpful for us to get data. Data is really important, right? And what we're doing is we're coming to these fact checkers. We're saying, OK, we have this nice tool that can help you to be more effective. And by the way, can we use a bit of this data that you labeled manually to train this model? And then maybe the tool will be actually even more effective. So that creates this nice dynamics, this nice feedback loop. So this is really cool. And this year we got recognized, we're very honored to get recognized by CB Insight as one of the game-changing startups, at least of 36 startups. We're also very humbled and surprised because I got to tell you, there's probably other startups out there that are much better funded and with bigger teams, but yeah, we'll take it. And yeah, so that's what we're working on, using ad verification, using AI for ad verification. And let's dive a bit more into the insides of the technology. So I wanted to share with you today specifically one example. This is quite recent. You probably know that Facebook has been struggling with eliminating fake news, right? So what they're doing, they're working with fact checkers. Like I mentioned before, these fact checkers go through these stories, and they manually label these stories as fake. But fake news is a spectrum, right? And somewhere in this spectrum, there's also satire. And you can't block satire. Satire is protected by freedom of speech. So what do? So Facebook put a different flag for satire. You have a flag for fake news and a flag for satire. But what happens next? All of these guys who spread fake news start to claim that they are satire. You see, they even carry this nice badge at the bottom of the site. You can't block us now, right? So this brings an interesting question. Can we identify what is satire and what is fake news, not by the source, like saying the Onion is satire and this site is fake, but by actually looking at the content of the story? So we started to think, what actually makes satire different from fake news? Any ideas? What do you guys think? The way, okay, so the style of the language, okay. What else? What's the definition of satire?
It's meant to be exaggerated.
Nice, yeah, so satire also has some humorous aspect, right? It's supposed to entertain. It has some also component of maybe absurdity. So we were wondering if we can use semantic and linguistic cues to try to capture some of these nuances, to tell the difference between fake and satire. And then we were wondering also, can we use these cues that we learn to identify things that will be able to tell us more about these nuances. So we trained two different methods, one for semantic features. We used BERT. You guys know BERT. BERT is from Google. If you are working on NLP, it's a very nice tool to have in your toolkit. It stands for bidirectional encoder representations from transformers. And in very simple words, it's a very advanced method. It's like word2vec, but much more advanced. So you know word2vec? Word2vec basically allows you to represent a word with a vector, and it also captures some of the meaning of that vector. So the word king will relate to the word queen, like boy relates to girl. So BERT is quite similar, but it's also contextual. So while word2vec generates one vector for that word, regardless of the context, BERT generates an embedding that depends also on the context. So the word king, in the sentence, the king ruled the kingdom, would have a different representation than in the word, I want to buy a king-size bed. Okay, so that's a bit about the semantic part, and then we trained a different model to try to capture the linguistic cues using a toolkit that is called coherence metrics. And what it does, it tries to represent how easy it is for a reader to connect between different ideas in the same story. So that's basically textual coherence. So we trained these two methods, and also obviously you need data for that. So we're very lucky that there was a work earlier in 2018 that the guys labeled 500 stories as real or fake, and they labeled them by the story manually. You remember we're trying to do that at the story level, not by the source. So that was really nice to see that we have this data set available. And then we compared the two methods that we discussed, the one with the semantic features with BERT, and the one with the linguistic cues with the coherence metrics. And we compared them to the baseline. The baseline that they did in the work was basically looking at the word and the words that are appearing in both texts. So for example, if the word Trump appears in the text, it's more likely to be fake, or vice versa. So basically a language-based method compared to the linguistic and the semantic cues. And you can see the results of these two methods are quite better. And also, this helps to answer our second research question. So first, we are seeing that these kind of features, the semantic and linguistic cues, can help to tell the difference between satire and fake. And then we looked into the feature importance to try to understand what's going on there. What kind of features are more associated with fake and what are more associated with satire. And what we saw is that features that are called causal connectives that are proven to be important for text comprehension, and also two additional indicators that are related to text readability. And what they are saying overall is the text that's appearing in satire is more hard to read or more sophisticated than fake news. So that's quite interesting. The data set is quite small, 500 examples, so it would be interesting to see if this can be generalized. So that's what we're working on currently, to try to extend this data set, but also a very nice insight so far. So that's quite a cool example for how techniques for NLP can be used to identify fake news and specifically to differentiate it from satire. Another example that I can share with you today, something also that I really like, it's not related to text, which we discussed before, but more to video. So this technique is borrowed from the forensic analysis domain. Okay, so they discovered that if you look at the videos and you zoom into the people, the human face, you can see slight changes in the coloring that are a result of the human blood flow. And as you can imagine, that you would not find it in a computer-generated video. So that's quite a good signal to identify what is fake and what is real. But you know, this is a cat and mouse game, so you know what will happen next. The generators of deepfakes will start to embed this. This has already happened before with blinking, by the way. So there was an article that if you you can identify fake by seeing that the person is not blinking. A few months later, the newer techniques have already learned to incorporate blinking. So this is how this thing works. I'm going to skip this example for the sake of time, but what we did here is we trained the classical machine learning approach. We trained the CNN on real and fake examples to identify what is fake. It works quite well, accuracy of near 90%. This is interesting. Have you heard about this? No? So Facebook announced that they're going to throw a deep fake detection competition. Our team is actually going to participate. So if you want to take a shot at prizes of millions, that's what they've been promising. And of course, eternal glory. So maybe come talk to me later to see if there's something we can do. And yeah, before I wrap up, what you can maybe take away from this talk. So we started by discussing a few examples for bad uses of AI. Okay, so we discussed the example with audio, for example, the Joe Rogan manipulation, examples with deepfake videos, example with text that is generated automatically. And what we're seeing is it's becoming more and more realistic, and it's also becoming more and more accessible. On the other end, we know that humans alone, we cannot manually label every story that's running on the social media, so we probably also need technology to help us with detecting these kind of manipulations. And we also saw a few examples for that. We saw the example with the NLP for detecting certain semantic and linguistic features that can help you to differentiate fake news, right? And we saw an example from the video area that you can use biometric signals maybe to detect deepfake videos. And yeah, before I wrap up, maybe I'll leave you with one more question to think about. So we know that this technology is going to continue to advance, right? We can't stop it even if we want to. And we probably don't want to. The question is how we can make the best use of this technology. Do we need the regulation? Because politicians are so technology savvy that they would know what to do with that? Do we need education people to educate people that this kind of manipulations exist? That probably couldn't hurt, right? Do you need technology people like ourselves to be aware of unintended consequences of their models? And try maybe even to build in some defense mechanisms? So there's no clear answers, but I think these are the type of things we need to think about if we want to win the fake news arms race. Thank you.